Hello class, this is Mr. Lehman. I want to talk to you today about the electron and where the electrons are found within the atom. And so this is the first of 3 or 4 different tutorials in which we'll learn about electron configurations and learn about the orbital diagrams and how the energy levels are broken up further in the sublevels and just the whole quantum mechanical model of the atom. So let's begin by looking at Niels Bohr. Niels Bohr came up with the solar system model back in the late 1910s. And we had a positive nucleus in the center, and then he thought that the electrons were traveling around the nucleus in these fixed orbits. He was incorrect in that they're not traveling around in fixed orbits, but he was correct in that there are different energy values for the electrons. And so electrons found in the first energy level, the first ring, are going to have a certain amount of energy. And then electrons found in the second energy level are going to be farther away from the nucleus, and the reason why they're farther from the nucleus is because they have more energy. So there's a value associated with electrons and how much energy they have in the second energy level. And then the third energy level have even more energy than the second and first. And then as the electron continues to move outwards and is found farther away from the nucleus, they have to have more and more energy. And so electrons in the seventh energy level will have more energy than the electrons in the first energy level because they're trying to resist the protons. The protons are trying to pull the electrons into the nucleus, and so the more energy an electron has, the more it can resist, and the farther it can be found away from the nucleus. Alright, so we have 7 energy level, or 7 different distances away from the nucleus. That's the first step. So when you see energy level on this chart that we're going to fill in together, energy level 1, 2, 3, 4, this is closest to the nucleus. And then something else I want to mention too is the first energy level, look how tiny it is. Right, in comparison to the other rings. So there's not much room for the electrons, whereas the second energy level has much more room. And so this is 2-dimensional, but remember atoms are actually 3-dimensional, so there's tremendously more room for electrons to move around in the second energy level than the first. And that's why more electrons can be found in the second energy level. Third energy level is even bigger than the second, so even more electrons can be found here in the third energy level. We're farther away from the nucleus. So let's look at this chart. So the first energy level has S sublevels and S sublevels only. And so this S gives us an idea of the shape of the region that the electrons are going to be found. And so this diagram shows us that the S is spherical, looks like a circle, looks like a ball. And so we have the X, Y, and Z axes. Where these 3 axes intersect, right here where my red dot is, that's where our very tiny, dense, positively charged nucleus is. So this green shaded area tells you the approximate region in which electrons will be found if they're found in the S sublevel. So each sublevel can hold a different amount of electrons. The S only has one shape or one type of orbital, and we'll talk more about that. So each orbital can only hold 2 electrons. So every orbital can hold 2 electrons. So the first energy level can only hold 2 electrons. Second energy level has both S spherical shaped homes, and there's only one type, one orbital, and that orbital can hold 2 electrons. But the second energy level is bigger, and so the second energy level has 1, 2, 3 orbitals. Each one of these models represents an orbital. And so what's different about these 3? Well, the P looks like a dumbbell. So the dumbbell-shaped orbital is, different than the spherical-shaped orbital. So it refers to different pockets of space around the nucleus. Once again, the nucleus is right here where all the axes intersect. And so the 2p, there's space above and below it. So this is the y-axis. So this is the 2p that falls on the y-axis. 1 electron can go here, 1 electron can go here, so we have room for 2 electrons. This is the third dimension, the z-axis. And so an electron can go here, an electron can go here, in front and behind the nucleus. And an electron, this is the x-axis, an electron can go here, to the left and to the right of the nucleus. So we have 3 dimensions. Each orbital falls on one of those axes. And so y-axis, z-axis, x-axis, each one can hold 2 electrons. So 2 plus 2 plus 2 is 6. So if we come back here, P sublevel, shaped like dumbbells, 3 orbitals, the one that falls on the x, the one that falls on the z, the one that falls on the y-axis. Each one can hold 2 electrons for a grand total of 6 electrons. 2 plus 6 gives us a maximum number of 8 electrons in the second energy level. The third energy level is even bigger. So just like the second energy level, there's going to be S, and there's going to be P's. And there's one type of S, it can hold 2 electrons. There's 3 types of P's, X, Y, and Z. Each one can hold 2. So the numbers stay the same. However, we have room for a third type of sublevel. So there's additional pockets of space that can hold electrons, and we call these the d orbitals, so even more complicated. So these are like double dumbbells, or we call them fan blades. And so each one represents one orbital, one different region of space within the atom that can hold electrons. So 2 electrons can go in this space, 2 electrons can go in these shaded regions, 2 more electrons can go in these shaded regions, 2 more electrons can go here in these shaded regions, and 2 more can go here. So 5 orbitals, 5 different regions that make up the d sublevel. Each one can hold 2, so 5 times 2 is 10. So 2, 6, 10, grand total 18. So up to 18 electrons can go in the third energy level, the third ring. And then the fourth energy level, and the fifth, the sixth, and the seventh all have 4 types of sublevels. Just like before, S's have 1 orbital, P's have 3, D's have 5. Each orbital can hold 2 electrons, and so we get 2, 6, 10 for the amount of electrons. The F is even more complicated. It has 7 different orbitals. Each orbital can hold 2, so a grand total of 14 electrons can go in the F. And so if we add it together, 2, 6, 10, 14 adds up to 32. So energy level 4, 5, 6, 7 can hold up to 32 electrons. In theory, energy levels 5, 6, 7 can hold even more, but we don't have any atoms that have more than 32. So what does the F look like? Pretty tiny here, but this is 1 orbital, 2 electrons can go here. Here's a second orbital, 2 more electrons. So each one of these pictures refers to one of the orbitals. And so 7 orbitals, that's where we get our maximum of 14 electrons. Alright, so that is the end of tutorial number 1, just giving you an idea of what we are talking about when we talk about orbitals and S, P, D, and F. So we're just trying to find the addresses of where the electrons are going to be found. So thank you, and continue on to tutorial number 2, please.